This video will show worked examples on radical equations and inequalities. So the first thing we want to do in any of these equations is isolate the radical portion. So here we can subtract 5 from both sides of the equation. We end up with the square root of x minus 3 equals 8. Now we want to square both sides of the equation to get rid of the radical. And this leaves us with x minus 3 equals 64. So x equals 67. And now we have to check this answer to make sure that it's not an extraneous solution. So we'll plug it back into our original equation. 7 minus 3. And indeed, this solution does check. Let's do the same thing for this example. So we'll subtract 4 from both sides, square both sides, x minus 9 equals 9, and then x equals 18 is our answer. Let's check that to make sure that it works. The square root of 18 minus 9 plus 4 and what we end up with is 7 instead of 1. So we know that this solution is extraneous. And that means that this equation right here has no solutions. This one is an equation with a cube root. So we can begin by dividing by 2. And now, instead of squaring both sides, we'll raise both sides to the power of 3. And that way we can get rid of the cube root, and we're left with 4x minus 1 equals 64. 4x equals 65. X equals 65 over 4. The square root of x minus 9 plus 4 is greater than 1. The first thing we have to do is determine the range of numbers for which x minus 9 can be taken the square root of. So we'll say that x minus 9 has to be greater than or equal to 0. X is greater than or equal to 9. And then we can go on to solve the equation. So we'll subtract 4 from both sides is greater than negative 3. Now at this point, instead of squaring both sides, we can just look at the equation. It is saying that the square root of some number is greater than negative 3. But we know that square roots are always greater than 0. So this means that this inequality is always true, or it holds for all x. Therefore, the only interval we have is less than 9 and greater than or equal to 9. We can check a number in each of these intervals. So in this interval, I'll check 0, and in this interval, I'll check 90. If I plug in 0, then I end up with the square root of 0 minus 9 plus 4, which cannot be found. If I plug in 90, then I end up with the square root of 90 minus 9 plus 4, or the square root of 81 plus 4, which is 13, which is indeed greater than 1. This means that our solution for the inequality is just x is greater than or equal to 9. Let's look at this inequality. Again, the first thing that we do is determine what x's we can plug in so that the radicand is greater than or equal to 0. In this case, this means that 2x is greater than or equal to -4, or x is greater than or equal to -2. Then we can take our inequality, add 3 to both sides. So we're trying to isolate the radical now. We can divide by 3. And now we'll want to raise both sides to the power of 2. Now we can just solve for x and say that x is less than 64 minus 4 divided by 2, or 30. This gives us an interval, -2, 30, x is between these two numbers. Now I'm going to choose some numbers to plug in. So in the first interval, I'll choose -4 to plug in. In the second, I'll choose 0. And in the third, I'll choose 48. So if I plug in -4, then I end up with 3 times the square root of -8 plus 4 minus 3. And that gives us a negative under the square root, so we can't do that. If I plug in 0, then I get 3 times the square root of 0 plus 4, which is the square root of 4, minus 3, which gives us 3 times 2 minus 3, which is less than 21. And finally, if I plug in 48, then I end up with 3 times the square root of 96 plus 4, or the square root of 100, minus 3, which is greater than 21. So 48 does not work. And this means that our interval is -2 less than or equal to x less than 30. For our last example, we'll begin by trying to isolate the radical. 2 times the square root of x plus 4 is less than -6. Or the square root of x plus 4 is less than -3. Now if we just think about this equation here, a square root is always at least 0, and it can never be negative. So this means that for all x, our equation does not hold. And so therefore, for this inequality, we have no solution.